Good morning, sir. I am studying first year BTech in SRIT college. Today my topic is PN junction diode forward and reverse bias. Subject name BEEE. Subject code 23EEE101. Student name M.Murali. Roll number 244G1A05p1. Branch Computer Science and Engineering. Importance of PN junction diodes in electronics. PN junction diodes are fundamental building blocks in modern electronics, enabling the control and management of electrical currents. Their unique properties allows them to function efficiently in various applications, making them indispensable for both consumer and industrial electronics. Key benefits of PN junction diodes. Exploring the benefits in electronics. Number 1. Low forward voltage drop. One of the primary advantages of PN junction diodes is their low forward voltage drop. This characteristic allows for efficient conduction, enabling the diode to operate with minimal energy loss during current flow. As a result, there are favored in applications requiring effective power management, high reliability. PN junction diodes are known for their high reliability, which contributes to their long operational life. This makes them an excellent choice in critical applications where failure can lead to significant consequences, ensuring consistent performance over time. Number 3. Wide ability. The widespread use of PN junction diodes in various electronic devices ensures their ability in the market. This commonality not only enhances accessibility for manufacturers but also simplifies sourcing for projects and repairs. Number 4. Versatile applications. PN junction diodes find application across a diverse range of electronic devices from rectifiers and voltage regulators to signal demodulators and makes them indispensable in both consumer electronics and industrial equipment. Cost effective. In terms of production, PN junction diodes are heavily cost effective. Their simple manufacturing process allows for economical mass. Them a preferred choice for manufacturers aiming to keep costs low while maintaining quality. Diverse application of PN junction diodes. Key uses and functions in electronics. Rectifiers. Rectifiers are essential electronic component that convert alternating current AC into direct current DC. This process is crucial for powering various devices and systems that require stable DC voltage, making rectifiers indispensable in power supply circuit. Voltage regulators. Voltage regulators play a vital role in ensuring constant voltage levels across electronic circuits. They protect sensitive components from voltages, thereby enhancing the reliability and performance of electronic devices that rely on stable power inputs. Clipping and clamping circuits. Clipping and clamping circuits are used in signal processing to control voltage levels and limit signal amplitudes. These circuits are critical in preventing signals distortion and ensuring that electronic signals remain within specified operational limits. Light emitting diodes. LEDs. Light emitting diodes or LEDs are semiconductor devices and that emit light when an electronic current passes through them. Widely used in display screens, indicators, lights, and general lighting applications. LEDs are known for their energy efficiency and long lifespans. Photodiodes. Photodiodes are a specialized semiconductor device that converts light into electrical signals. There are employed in various applications include communication systems, light meters and sensors enabling the detection and measurement of light intensity and wavelength. Understanding reverse bias in semiconductors. Key concepts and implications of reverse bias. Number one, connection of P side and N side. In reverse bias condition, the P side of the semiconductor diode is connected to the negative terminal of the power supply while N side is connected to the positive terminal. This arrangement reverses a flow of current which is crucial in controlling the diode's operation. Number two, depletion region expansions. This connection causes the depletion region within the diode to widen significantly. The increases in the depletion region prevent charge carriers from crossing the junction, which is essential for the diode to block current under normal reverse bias condition. Number 3. Current flow limitations. Under normal reverse bias condition, the diode prevents current flow except for a small amount known a reverse saturation current. This tiny leakage current is critical for understanding diode behavior that is generally negligible in practical applications. Number 4. Breakdown mechanisms. If the reverse voltage applied across the diode exceeds a certain threshold, it can lead to breakdown. The breakdown to occur through such as avalanche breakdown and Zener breakdown, which can either be controlled or lead to device failure depending on the design and the diode. Understanding forward bias characteristics, exploring key properties of forward bias in diodes. Number one, current flow. Forward bias conditions lead a significant increase in current when a minimal increase in voltage is applied across diode. This highlights the diode ability to conduct electricity efficiently, making it a vital component various electronic circuits. Number three, IV curve. The current voltage 1/5 characteristic curve of a diode under forward bias depicts an exponential increase in current as voltage rises. This curve crucial for understanding how diodes operate in circuits and is essential for designing electronic devices. Number 3. Power dissipation. As current flows through the diode in forward bias, it generates heat due to power dissipation. This aspect is important to consider in circuit design to ensure that the diode operates with safe temperature limits and maintains reliability. Number 4. Example of silicon diode. A common example of forward bias can be seen in silicon diodes which begins to conduct significantly when applied voltage approximately 0.7 voltage. This character is fundamental such as rectification and signal modification. Understanding forward bias in diodes, exploring the mechanism of diode conductivity. Definition. The forward bias conduction in a diode occurs when the P side is connected to the positive terminal of a power supply while the N side is connected to the negative terminal. This setup allows the diode to conduct electricity by factorizing the movement of charge carriers. Effects. When a diode forward biased, the width of depletion region significantly reduced. This reduction allows for a laser flow of current through the diode, enabling it to conduct electricity efficiently when the necessary voltage is applied. Charge carrier activity. In a forward biased diode, charge carriers such as holes and electronics are allowed to remain. This recombination process is crucial. It results in the flow of current through the which is essential for the functionality of electronic circuit. Voltage requirement to initiate conduction in a forward bias diode. A small voltage is typically required for silicon diodes. This voltage is around 0.7. This through essential of overcoming the potential and allowing current to flow. Working principle of PN junction diode, exploring how PN junction diodes operate under different bias condition. Forward bias functionality. In a forward bias configuration, a positive voltage is applied to the P side of the diode. This allows the majority carriers holes in the P-type material to move towards the junction, while electronics from the N-type side move to the junction, as will facilitating current flow through the diode. Number two, reverse bias functionality. When reverse bias is applied, the positive voltage is connected to the inside, which creates an electronic field and voids with depletion region. As a result, the majority carriers are pulled away from the junction, efficiently preventing any current from flowing through the diode export for a small leakage current. Number three, behavior of charge carriers. The operation of PN junction diode is significantly influenced by the arrangement of charge carriers in the depletion region. The electronic field generator play a crucial role in determining whether the diode allow or block current flow depending on applied voltage. Understanding the structure of PN junction diode. Key components and their function. P-type region. The P-type region of PN junction diode characterized by surplus of holes which are the majority charge carriers. This region is formed by dropping semiconductor material with elements that have refer valence electronic creating positively charged holes to the facility of flow of current, voltage and applied. N-type region. In contrast to the N-type region consists of region as majority carriers. This area is created by doping with elements that have extra valence electronics, leading to negative charge electronics in this region can move freely, making it conductive for current flow current when subjected to electric field. Depletion region. The depletion region is a critical area within the diode where mobile charge carriers are divided this zone from a electric field due to the recombination of holes and electronics, creating a barrier that prevents future charge carrier movements. Thus, it plays a virtual role in the diode functionality, allowing into current flow efficiently. Junction. The junction is the interface between P-type and N-type materials. It play crucial role in the operation of the diode. It is electric field established the junction determines the diode ability to allow current to flow in one direction, blowing in the position. Understanding PN junction diode, exploring diode operation in electronics. Inter Introduction to PN junction diode age. PN junction diode is a semiconductor device that allows current to flow in one direction when blocking in it the opposition direction. This presentation focus on its operational principles under both forward and reverse bias conduction of various electronic applications. Forward bias conduction. In forward bias conduction, the positive terminal of the voltage source is connected P-type and negative terminal to the N-type material. This configuration reduces the potential barrier, allowing charge carriers to flow, resulting in a significant increase in current through the diode. Characters of forward bias. Under forward bias, the diode exhibits a low resistance with the current flow becoming exponential relative to the applied voltage. Understanding this behavior is crucial for designing the voltage of a signal modulation. Reverse bias connection. In reverse bias, the connection are rapid, leading to increase in potential barrier. As a result, a diode black current experiences a minimal leakage current which occurs due to minority charge carriers. This characteristic is visual for applications such as a voltage and region. Characteristics of reverse bias. When the reverse bias maintains a high efficiently reflects significant current flow. The reverse breakdown voltage parameters including the maximum reverse voltage the diode can withstand without undergoing damage. Thank you, sir.